Hello, welcome to this webinar on cost optimization for existing workloads in public cloud. My name is Alan MacDonald, and I have here with me today Jeff Barnett, Victor Dantes, both senior cloud architects at professional services in Basefarm. Today, we're going to talk about cost optimization. What is that? Cost optimization is a process where you seek to minimize or reduce your cloud spend, and of course, adhere to your business requirements, and also make sure you keep up your service level as well. So without further ado, I'll throw out the first question. So hi guys, when you meet the customer first, how do you approach them, and what do you think of first when you talk about cost optimization with them?
Yeah, so first of all, when I'm talking to a customer, first of all, I'm looking to see what their goals are, because every customer has different needs. So cost optimization is only one aspect of actually running an IT system. So there could be some other priorities which override it, such as, you need to be able to keep a certain level of availability, you need to be able to meet certain service levels. So what we need to do, first of all, is establish the customer's priorities and what they're looking to achieve, and then work out how we can still minimize the cost in a way that still delivers to the service levels that they want and the level of security that they require as well. So first of all, what we want to do is get an understanding of the system, its use, who the user community is, and any requirements that they have, regulatory requirements, localization requirements that they need to keep data in certain regions, etc. So we start with that and then work out what our limitations are, and then from there kind of look at how we can optimize the services within those limitations.
Yeah, I think understanding those priorities in the beginning is important to even know what cost optimization means to that particular customer, because cost optimization is not always necessarily just lowering costs. You need to take into consideration what the priorities are, what the trade-offs are. If you have performance to take into consideration, if you have reliability to take into consideration, cost optimization is not going to be necessarily lowering costs, but making those performance goals and reliability goals, for example, be met in a cost-effective manner. So it's about those trade-offs that we need to balance all the time.
So basically, you're looking at what their business requirements are and how they go to market, and you make sure that whatever you start to do after that is in line with that.
Yeah.
And then I suppose as well, when you first interact with the customers, there are easy, I don't like using this expression, but easy, low-hanging fruit that can be, fixed quickly. And then I guess also there's a number of different types of tools you can use as well. So how do you approach it from a customer perspective? Do you go in and let them, educate them, or do you go in and then start looking in at the environment and look at what you can change yourself?
Yeah, I mean, when we talk about low-hanging fruit, I mean, a lot of these things are things that customers can look at themselves. So, and they will certainly be the first things that we look at when we look at an environment, just to see, how the customer is running the environment already. One of those is looking at, it's particularly if they're using VM instances or EC2 instances, on their public cloud, we can look at, how well utilized those instances are. And there are tools also that customers can use, such as AWS Cost Explorer, Azure Advisor, or GCP Recommender, that can actually give the customer or us some insight into how resources are being utilized, and also recommend better instance sizes, or when the instances are utilized at different times of day, maybe make it recommendations about when to shut instances down and things like that, or different pricing models that they can use to purchase those instances, whether they're on demand or reserved pricing models. So certainly you can use those tools as a basic thing to minimize services without doing really any architectural change. So it's quite an easy thing to approach from a start, and it's quite a quick and easy way to look at reducing cost without doing too much.
Yeah, and I think it's also important from the beginning to have cost visibility to begin with. So having, first of all, understanding how you're being charged, because it's hard to even think of how to save costs if you don't know how your resources are charged. And that could be, is it by the hour? Is it by specific units of consumption? So you need to understand those things first. And then understand the tooling that you have in your specific cloud provider to visualize costs and see how they break down into the different components. And ideally also have a budget set and some alerts that you can get so that you get notified when things start getting out of control, and so that you can have more visibility into how your consumptions are being charged. So having a visibility, and like Jeff mentioned, the right sizing is really the low-hanging fruit to start with. Making sure your workloads have the capacity that is a best fit for them. Not too much, not too little. And that's an exercise that you need perhaps some time running their workloads to understand what those performances and capacity allocation will be that will be most cost effective. And like Jeff also mentioned, we have tools in the platform. Azure, for example, has the advisor. AWS is trusted advisor or the cost explorer that will give you recommendations based on the workloads that you have running on what you can potentially downsize because the VMs haven't been running at too high a capacity for too long. So maybe they could be downsized to save some costs. So those would be a good place to start.
Okay. You mentioned best fit. And I guess there are different fits for different customers, of course. And then I suppose from a standpoint, from a baseline, you go out from different frameworks and best practices. I mean, public cloud has been around for a number of years now. So there are definitely the different CSPs, different cloud service providers have different frameworks and best practices in place. How much do you use of them, and how different? It's a follow-up question as well. And how do they differ between the different CSPs?
Yeah, so I mean, so all three cloud providers really they have like some kind of concept of like a well-architected framework. They are roughly the same with each of the cloud providers, albeit that the services that you deploy on with each of the cloud providers are different. But the way that you tend to look at things is a similar process in terms of, well-architected framework usually has like 5 kind of key areas that you kind of look at, and the cost optimization being one of them. But then you also have like other areas like security, governance, operational efficiency or operational effectiveness, and the last one?
Cost optimization.
Yeah, and cost optimization. Yeah, of course. Yeah. So so we would look at all of these. Normally, when we engage a customer, actually, we won't just look specifically at just cost optimization. It might be a particular focus for the customer, but what we also want to do is actually look at all 5 kind of pillars of the well-architected framework to address all of them, together in terms of how to optimize the workload and how to make sure that it's secure and being well managed, and also using like appropriate services, to deliver the capability, in a reliable way. So we never really do cost optimization in isolation. We always do it in tandem with working with these other areas as well, because you can always optimize for cost, but it can have an effect in other areas. So you could optimize for cost on a database service, for example, by reducing it from 2 nodes to 1 node, but that might not be a good idea because you want to have that kind of resiliency available in case one of the nodes goes down. So we always need to look at everything together in this kind of balanced way.
And then if you look at following on from the different type of frameworks that are in place, then you can think about different services and different cost models provided by the CSPs. Can you elaborate a bit more about, you talked a little bit about resource sizing and seeing what the best fit is. How do you actually do that from a when you get down? I mean, today, or not today, but always, cloud is based on like networking, CSP, RAM, and storage. Do you go down on that level and then start looking at where you can optimize from those levels?
Yeah, I mean, you can try and get very granular with your resource allocation, but ideally, you should actually try and aim for managed services in the cloud. Those are platform as a service offerings that will offer some kind of elastic scalability, or even serverless services where you're really only paying for those units of consumptions. So it might be CPU time, it might be requests, it might be the network usage, it might be a combination of these things. But essentially, if you're not using the service, you're not paying for anything. That's the premise of serverless. But at the very least, it should have an element of scalability that is automatic, so that if your workloads can scale out or up to meet the increasing demand, and then also, most importantly, to scale back in to when demand is lower, then you'll be able to have the most cost-effective solution without having to worry about capacity allocation, or without having someone needing to act all the time on those right-sizing features that we mentioned before. And just one thing to mention also on the subject of VMs and sizing VMs is the reserved capacity, which is actually something that can have really huge potential for savings. It's not unusual to have more than 50, 60% of savings just by reserving capacity for 1 year or up to 3 years. So basically, if you know you're going to be running VMs for a while and you know your baseline capacity needs for those VMs, you can reserve that capacity with the cloud provider for 1 year or 3 years and then get some really big savings there. So that's one big win. And if you can move those VMs to a managed service and a serverless service, that would be the ideal end goal to aim for if you want to have a cost-effective solution, I would say.
Yeah, I want to expand a little bit on that with regards to like kind of reserving capacity, because each of the cloud providers has a different offering in the way of doing that. So for example, on Azure you have the opportunity to do like reserve capacity. On AWS they have the opportunity of doing reserved instances, or you have an option called a savings plan, which basically is a commitment to buy a certain amount of compute, regardless of what kind of instance type or you're using, across a billing period of a month or a year. So with AWS, you might have more flexibility about being able to say, I know that I'm going to spend X over a certain amount of time, and then I can change my mix of instances as I want to, in order to be the most cost effective. And then on GCP, you don't tend to have to worry so much about actually managing instance types, because what happens with GCP is that GCP has what's called a sustained use discount, which means that the longer you use a type of instance within a specific class, or the more you use a specific class of instance, the higher the level of discount that you'll have for using that consumption, and that's automatic. So in GCP, really, what you just need to focus on is using specific classes of instances as much as possible in the same class, so that you can maximize the use that discount level. So there are different approaches for each of the different cloud providers about how you do that. And then I want to also talk a little bit about the elasticity side. Because there are also patterns that you can use to increase your use of elasticity or to get better cost effectiveness in that. Not every application is able to support elasticity, particularly if you're migrating something from on-premise or an existing off-the-shelf product. Depending on how the application manages kind of session state, you may not be able to scale in as easily as you can scale out, and also scaling out might also be difficult. But if you have a fairly modern application that is tracking session, or session state, centrally within storage or a database, or within a client cookie, then usually you can scale the application fairly easily. And then you don't need to worry so much about warm up times and cool down times for those applications to scale. You can also, with some of the cloud providers, use things like spot capacity as part of your auto scaling requirement. So you can place a bid on a capacity being at a certain price, and if it meets that lower price, you can use the spot capacity within the auto scaling group. And then when that capacity is not cheap enough, then you can use on-demand instances, for example, instead, and use a mix of that within your auto scaling in order to reduce the cost of running the consumption, dependent on how much spare capacity the cloud provider has at that time. So there are things that you can do to cost optimize those workloads like more efficiently. They're more complex, but they can get you real gains in terms of running services at a low cost.
Yeah, I was just wondering, a lot of questions I hear about is bringing your own license. And especially when you're talking about elasticity and you're scaling up, then you're probably going to scale up more machines and more licenses are necessary. How does it actually work? How do you tally off of using in sort of like a SaaS setup where the licenses are included, or bring your own? Is there a time when, if you bring your own, that your licenses are used up? Or how does that actually work? Can you explain that a little bit about how bring your own licenses, or which is the most advantageous?
Yeah. So for me, I normally try and recommend customers where possible not to bring existing licenses to the cloud, but to purchase licenses through marketplace, or through the cloud provider, because it's a lot easier to manage the licenses in that way. And you can, and in that case, the licenses are charged on the billing unit of the instance. So it could be like per hour, per second, or per day. Sometimes there are minimum billing periods for certain types of licenses. But that's always a lot easier to manage. There are also tools to help you manage. So recently, AWS, for example, expanded their AWS License Manager to work organization-wide. So if you have many accounts within your AWS organization, you can actually set a limit on the number of licenses, and it will stop you from scaling past a certain point. So that once you reach your license ceiling, then it will stop scaling across your organization. That's a fairly new capability. I haven't worked with it yet myself, but it's definitely something that you can do if you absolutely have to, or if you have like an unusual license. But you have to remember that if you are doing this kind of scaling, that once you reach the limit, you won't be able to scale any further because the system won't allow you to go into breach. On other cloud providers, it's not always as easy to be able to manage licenses organization-wide. And so you need to set a limit for your scaling, and remember that you're paying for licenses that, full-time, that you might not be using all the time. So you're not always getting the best cost benefit out of doing that.
Yeah, moving to a more OPEX model that you have in the cloud, where you're paying as you use, and you have the license prices included, are really the optimal way. Financially and just from a cost-effective perspective. But that being said, in Azure, if you have existing Windows Servers license, for example, or SQL Server licenses, and you have software assurance, you can bring those licenses to the cloud to reuse them, so you don't have extra costs. So that's one thing to keep in mind if you are migrating workloads from on-premises. But if you are cloud native, or if you have been running the cloud for a while, then you might want to leverage that license-based model where the license is included in the price.
Is it possible to use a combination of bringing your own and scaling up with?
Yeah, you should be able to combine those.
It varies by cloud provider. It can. So, particularly with Microsoft licenses and instance-based licenses that are based on a physical host, it can be more difficult to do that kind of licensing in the cloud. So if you have a license that's tied to a specific physical host that you're moving from your data center, what you may need to do is use like a dedicated host option from either AWS or Azure, or use some kind of bare metal option in order to make sure that license is always attached to that specific physical unit inside the cloud provider's data center. I think this doesn't give you a lot of flexibility, and this is one of the reasons why I like to avoid customers, to recommend that customers try to avoid doing that, because one of the reasons that you want to use a cloud provider is to use the flexibility, and the way that you design, for resilience in the cloud provider is that you allow things to fail, and you expect to be able to restart instances, somewhere else, either in another availability zone or in another region. And if you have like a license that forces you to use it on a specific unit, either you're having to buy multiples of that license so that you can designed for that availability, or you're sacrificing the ability to move that license in the event that you have a problem. So normally I would normally recommend customers against using those kinds of license models as much as they can. But if you absolutely have to, then there are ways that you can mitigate that.
That begs the question also. I suppose, with cloud, one of the advantages for PaaS is that, you give the opportunity to developers to have their own environment and to work on a non-production environment. And I guess when they go home and leave the office, those things can be closed down pretty easily. Then that also brings up the thing is, from the other side of that as well, I guess you can also schedule batch jobs for production in the nighttime. Or that must be an advantage. Is there a cheaper price for things which can run in the nighttime or off peak times, or does that make any difference?
It might not make difference what time you run, but you can definitely. So, for example, in the case of developers using compute power during business hours, that's very often the case that you don't need any of those resources. You don't need them to continue to run into the night and on weekends. So one thing you can do is to shut them down. Ideally, you want to have an automation solution so that happens automatically. So, for example, if you don't have a global team working on different time zones, and you have a set, business hours that your developers are working in, then you might want to schedule shutdown of VM resources or all the resources that are incurring costs outside of those hours. And also during weekends, that's a big, huge savings opportunity there. And for running batch and bursty type of workloads, one recommendation there would be to use spot instances or preemptive instances, as they are sometimes called. These are very cheap VMs that are offered when the cloud provider has excess capacity that they want to basically offer you as a cheaper price. It's not always available, so you shouldn't have something that is important there. Some production applications shouldn't be running those instances. But if you have a bad job that is not time sensitive and you can wait until there's capacity for it, then you can leverage those types of VMs that are much cheaper than regular ones. So that would be...
Yeah, that's definitely the case. I definitely advocate for using spot instances or preemptive instances wherever you can for batch jobs when you don't need to run that job exactly at a specific time. Then that's a really good way of doing that. Other things that you can do is you can use things like the queues that are available within the cloud provider, so that you can queue up jobs so that you can then have them launched at specific times when they hit a specific batch number, and that can also help you then use an on-demand instance, for example, just when you have a certain number in the queue, rather than keeping the instance up all the time, in order to take items that are not time sensitive and process them one by one. Just wait till you have a batch of like 15, 20 or 100, start an instance and then, process all of those and then shut it down. It's another way of kind of reducing like the compute time that you need to run.
We spoke about mostly CPU power and running instances and so. Well, what about storage? Is there different types of pricing for long-term storage? Is there different types of pricing for the size of data and how often you read write? And how do you look into those kind of things as well for storage?
Yeah, well, you've got different types of storage available in the cloud. I mean, you obviously have, if you're running like virtual machines, then you obviously have the storage that's attached to the instances. And that's available usually in different qualities or different tiers. So you can have slower speed, like magnetic disk or SSD or high performance SSD normally with each of the cloud providers. The options vary based on region, instance type, and which cloud provider. So you have different options for that. But then also ideally, you're trying not to store storage on the instance, but actually store it in one of the cloud providers' object storage services, such as like Amazon S3 or Google Cloud Storage in buckets, or Azure storage accounts. Again, using bucket object type storage, because that storage is a lot cheaper. And there are tiering arrangements also available with these types of storage that allow you to, move less access data to cheaper types of storage. The pro of that is that you can keep long-term storage for longer, but the con of moving it to a cheaper storage is that usually there's a cost for accessing that storage when you do need to do it less frequently. So it's good for, doing archive and backup where you don't expect to be querying that storage like regularly, because there is a charge for doing a query to the tier levels that are not like the live storage tier. But that can be like a good way of keeping, archive and log data or, older customer data that you're not needing to access as frequently.
Yeah, and one thing to mention also on the storage accounts is to have some life cycle management around that, because it's usually a big cost driver to just have stuff lying around there that is not needed anymore. Or if you have object versioning enabled and you have multiple versions of the same object, then you have those multiple copies that are kept around, if that's a feature available. Then you can have some sort of life cycle management in there to make sure that those older versions are removed when they're no longer needed, and you only keep a certain number of versions that you find necessary. And the access tiers, as Jeff mentioned, is very important. Very good way to save costs. Also, if you have data that you're just keeping around for compliance reasons or archival reasons, you don't really need to access them very often, then you can use that to save costs. And for databases, there's also some right sizing that you can do. And in the same way that you do with your VMs, you can find the right match of, speaking of relational databases, right? You would have one instance that you would configure in terms of CPU and memory and storage and IOPS. So trying to find the best fit there for your workloads. If you can have data in a non-relational database, if you have non-relational data, then those tend to scale automatically, and you would pay by the amount of storage that you use and the amount of underlying compute that is really necessary to serve requests. So those would be very effective. And finally, just think about your backup. Don't do more backup than you need, because you, of course, pay for that extra storage. And if you have backups being stored in other regions, that's very good for availability and resiliency, but there's a trade-off there to consider, because that's extra cost, not only in storage, but also the network that is going on between those different regions. Because network is often neglected when it comes to cost, but you're paying for inter-regional traffic or sometimes interzonal traffic also. So just be aware of that trade-off there.
Yeah, I want to circle back a little bit to that point about having elasticity within the database and the database storage as well. Because until kind of like a year ago, it was the case that normally you had to provision your capacity up front for all like relational database services and all of the cloud providers. But there are now starting to emerge options for actually relational database services being more elastic. And one example of that is Amazon's Aurora serverless services, which are now available for MySQL and PostgreSQL workloads, but only in specific regions.
Also Cloud Spanner on GCP.
Yeah, and Cloud Spanner as well. Yeah, but Cloud Spanner is available globally, but for some of the other services, they're only available in specific regions because they're still fairly new services. So it's important to look at also the region that you might deploy your services in if you want to take advantage of services like that. With all of the cloud providers, there's normally specific regions in each geography that get access to services more frequently. In AWS and Azure, so in AWS, like within Europe anyway, it's usually the Ireland region, but usually West Virginia is always where first services usually come up, globally. And then in Azure, you usually normally looking at EUS1 as the primary region where new services are deployed first. And then GCP is a little bit more varied. But usually it's a US region where it comes up first. So if you are the kind of company that wants to take access of the newest and most cost-effective services or managed services, you may want to look into your region strategy about where you look to adopt that. A counterpoint to that is that if you are using infrastructure as code to manage your IT infrastructure, and you are deploying the same services or the same application in multiple regions for compliance regions, you may want to be more consistent about the services that you are using in all of those regions, because it basically lowers your operational overhead to write code once that can tap into the same services in each of the regions. And so using the most modern services might then be a detriment in terms of total cost of ownership, because you would need to write, have somebody that understands how each of those different services work, and you're working with several different design and deployment patterns, which might make it more difficult to support. So you do need to balance that, with your cost optimization against your human cost and the cost of resources.
So basically, we went from talking about fine-tuning existing workloads in the customer's environment. Now you've started to talk about moving on, possibly moving even regions. And that would mean, because of there may be services that are better than the existing ones that they have, and that they exist in the new regions because they're launched maybe in a different way in those regions. How do you approach that? Because it could be a big thing for a customer, but also for the laws that are around today. You have to take jurisdiction into account, for instance. Mm-hmm. So there can be pitfalls when you talked about as well the costs between different regions. But is it often that you go there and you say, oh, maybe you can start up a new region in some other country and then lift everything over, or how does that tally? Does that often happen?
It is something that I have recommended to a customer. Normally, if you are looking at like a customer that's only operating in the EU, there isn't really any legal impediment to operating in any of the EU located regions on any of the cloud providers, because the EU has kind of harmonized legislation. Now, there may be that customers still insist that they want to keep something in a specific country or other type of geography, and then that can obviously put a spanner in the works. But in general, where people are just following the current legislation, there isn't an impediment to using any of the other regions within the EU if you're operating solely within the EU. So using another region, you may look at using a specific region because of a low cost, or you may be looking at a different region because of an availability of a service. So, for example, the Stockholm region on AWS is one of the cheapest regions to run compute in Europe, or in fact the world. So it's a very good location to deploy if you are looking to run, the standard service, the most widely available services in AWS, for the cheapest cost. But it doesn't get the newest services as quickly as a region, for example, like Ireland. So if there is a particularly good service that you want to use, so one of the examples, for example, I made to a customer was about using this Aurora serverless product for their databases, because they were looking to run a lot of small databases for different customers that they had. So actually using the Aurora serverless product would have been a real key cost optimization if they could use that in a region that was available to them. So in this particular case, there are reasons why you might look at different regions, for specific types of services, or potentially even different cloud providers if you are multi-cloud, because of cost, of storage, or cost of running a particular type of workload.
Yeah, but primarily to build new things, right? It's not that you need to be watching out for cheaper regions and moving stuff around. That will probably be too costly, but building new things and always balancing the costs of the savings that you get from compute and storage and whatever else with the network. Because if those application components need to communicate with other application components in other regions, then you need to balance that out with the cost of the network egress between regions also.
I picked up, you mentioned IAC, infrastructure as a code, a few minutes ago. And I was just wondering, can you explain how that works? I mean, if you have a region up and running and you're running in an environment and you have that scripted as templates in as code, can you just use that code and, so say, bang it in someplace else without adjusting it too much? And what kind of, you can obviously then build something very quickly. That must be also a possible cost saving for future expansions. And so how does that fit into the whole? Because that's one of the advantages of cloud, that you can actually set something up extremely quickly, I suppose.
Yeah, as long as you've parameterized your infrastructure as code like properly, then it's very easy to move like a piece of code that you've developed to deploy resources from one region to another. But it does mean that you do have to parameterize that code. If you just go into the cloud provider and select there, export this environment to infrastructure as code, you're not going to get like a parameterized piece of code that you can replay. You can replay that in that region, and it will deploy roughly the same resource that you that you had before. But the real way to do that is if you are developing the infrastructure as code and you are parameterizing in the right way, then you should be able to set the parameters for each region and then redeploy that code multiple times over and over again. And reusing the code, like building, it depends on which infrastructure as code tool you use. So, I mean, for each cloud provider, they have their own infrastructure as code tools. So for Azure, you have like ARM templates. For AWS, you have AWS CloudFormation. And on Google Cloud, you have Cloud Deployment Manager templates. And while they work similarly, there are differences between each of these different offerings. And then there's a third-party offering called Terraform, which is generally what we would prefer in Basefarm. And the reason that we prefer that is that we are able to manage resources in each of the cloud providers with the same tool, and actually have like a one template that can build, a database in Azure with, we could then use AWS's CloudFormation and a web service in AWS, and then maybe have like a connectivity to another application in GCP. And we could build all of the components in all three of those clouds, using one deployment in Terraform. Whereas if we were using the cloud provider's own infrastructure as code tool, ARM templates could only provision, resources in Azure. CloudFormation mostly only configures resources in AWS, although you can extend it in some ways. And then in Google's Cloud Deployment Manager, again, it's really for deploying stuff in Google. So you have the concept of being able to use modules in some of these infrastructure as code tools, but the main thing is that you're able to redeploy these templates in different regions, different geographies, or in different projects or accounts or subscriptions.
Yeah, and from a cost optimization perspective, the real benefit of infrastructure as code is that it gives you the reliability in your deployments, and the repeatability. Also, you know exactly what you're getting because it's defined in code. So you eliminate that environment drift problem where, people start doing manual configurations and then your environment starts to deviate from the original design. And that has some indirect costs associated to it because the issues may creep in and you might have problems that later it's going to cost you in terms of operations and just taking people away from their work to find what the issue was and to remediate it. So having that reliability component that you get from ISC, infrastructure as code, in the long run is a cost-saving strategy, for sure. And just having that agility also that you give to your teams, being able, especially if you have an immutable infrastructure approach where really everything that's in the template is overriding whatever it's in the environment, then you can quickly move things around. And if you need to redesign the environment or if you did something wrong, you need to roll back, you can do that very quickly. So that increases the agility, which means you free people up from doing work of redesigning and re-implementing, and they can be working on more value-add activities, basically.
Yeah, and if you are also integrating your infrastructure as code with a CI/CD pipeline, you can also enable build pipelines for your infrastructure as code as well. So effectively, what then happens is that when you commit a change to your infrastructure as code template to your Git repository, you can then immediately have that process build that code immediately in your environment. So trigger the deployment and start it off, with the kind of minimal interaction from other people. You normally want to put in like an approval process where you click, are you sure you want to apply? But you can also build in things like validation. So normally you will get some kind of diff result that says, this is what's in the environment at the moment. These are the changes that are, that are different, from this new version of the template, from what's currently deployed in the environment, the current state. And you can verify, what's being modified, what's being replaced, what's being deleted, what's being created. And it's a very easy way of being able to manage change in your environment. Another benefit of using Git to do that is that also you have the version history of those templates. So it's very easy then to kind of go back to a previous version of that template and then redeploy it to the environment again if you've made a mistake and something, has broken. So it's a really great way of managing the environment, and it can reduce the cost of doing deployment and speed up, how you introduce change to the environment.
I was wondering then, when you've done this and you made a review of a customer's environment, and if you then implement all of these improvements and changes, and then depending on the customer's managed service setup, when you leave, then I suppose there's maybe a retraining has to be done at the customer side, how to use all of these things, not to get back into bad habits. There's monitoring that has to be put in place. I guess tagging, categorization, classification, labeling is very important. When you then leave, how comfortable is the customer, that what you've implemented will, continue to be cost efficient, so to speak? What are the things which have to be put in place? Is it just simply retraining or mindset change, or what do you leave the customer with besides a new environment?
So yeah, definitely there is a cultural component that we need to think about. So it's ideally customers should be thinking of working in a more DevOps manner. So, having your operations and your development team working more together and having a shared responsibility model where everyone's a little bit engaged with everything along every step of the process. And also having a mindset that each application team manage their own application and the entire end-to-end life cycle of it. So being responsible also from how they're deploying the resources, how those resources are tagged, and how they are being consumed and how much they're costing. So having that responsibility ideally being taken up by the very application teams that are managing those applications. So, it's not about trying to deliver something and then moving away and having that handed over to, operations team or whatever. It's that whole discussion, right, of how DevOps can benefit organizations is by bringing the teams together and stopping with that, old paradigm of handing things over to operations. And training is a fundamental component of it as well, because you want to have your team upskilled to have those modern practices, especially around coding, because infrastructure as code, even though it is not necessarily programming, but it is, it is a different skill than what operations teams might be used to. So training is fundamental, and having that shared understanding in that DevOps culture is very important.
Okay. Yeah, I want to circle back a bit around to the development teams taking ownership of the products or being able to assign ownership to specific resources, and for development teams in particular to own the costs themselves. So one way you can do that is that you can, apply tags to resources and then use that, within your cost reporting to say, these costs are incurred by this development team. And another way that you can do it is actually you can segregate, with accounts or subscriptions or projects. So in Azure, it will be a subscription, in AWS an account, or a GCP a project. And this particular entity then is like a domain that people can operate in. So you can be assigned the capability only to create resources within a specific project or account or subscription. And then the ownership of that project is then to a team. So it's another way that you can look at doing that. So then using, multiple accounts or subscriptions or projects is one way of basically making sure that, that which team or which application, is responsible for driving which cost. And that's probably more common now, especially with bigger companies that we're looking to do that kind of model instead of using tagging, which has been a more traditional method that people have been using for quite a while to do the same thing. But I really recommend looking at using more accounts and more subscriptions, and then having like an account per application, and then that application being managed by a specific team. It really helps to kind of make sure that who owns what cost, and then hold them accountable for that cost.
As you modernize your practices, you also want to think of modern architecture patterns like microservices, for example, where you have different application components being deployed and managed independently, which not only facilitates this whole culture of having different application teams taking care of different components, but also from a cost effectiveness perspective, if you have different application support and different microservices, you can scale them independently. Then you can be very granular and very efficient with how you allocate resources to each different component, as opposed to having a single monolith where you have to scale everything together as a big unit. So it's more efficient way of working in the cloud if you lean towards those more modern architectural patterns with microservices. And finally, from a governance perspective, you want to make sure you have some guardrails in place, like things like policies, or you might want to restrict the regions where resources can be deployed, or restrict the specific SKUs and sizes of resources that can be deployed to prevent people from deploying very large services that are not really necessary for your applications. So putting those guardrails in place and having that shared understanding so that everyone knows why these guardrails are in place, and that the idea of the business is to allow people to move fast and have agility, but also have some protections that would prevent things to be done, even by mistake. Sometimes they just wind up deploying a service that is too big or unnecessarily high performance for your needs. So finally, I would just want to mention also on the governance subject that you might want to think of considering security as something that not necessarily directly affects cost, but it's like an insurance policy that you have, right? Because if your environment is secure, you are preventing some events from happening, potentially some really high risk situations where you have an identity that is compromised or your environment is compromised, and that can cost a lot of money down the road. So having a secure environment from the ground up, from the governance, from the practices that you do in the beginning, like a DevSecOps approach, would be a way to ensure that your environment will be secure and would prevent potentially very high costs from occurring at some point.
Yeah, that's definitely the case. That in particular with denial of service type of attacks, and a way that denial of service type attack occurs is that basically attackers can use a lot of resources to make your system serve more content, to serve more, to increase the capacity of your service. So if somebody is using a botnet, for example, against your service, the idea is to kind of flood your service with and make it so that you have so many requests that you aren't able to respond. And then what your environment will do, if it's kind of designed to auto scale, is that it will keep adding resources to your auto scaling group or your scale set to meet that demand. But effectively the botnet's capacity is unlimited, but your resources aren't, and you don't want your cost to scale too much. So key things to do are to make sure that you are setting limits on how far your auto scaling groups can scale to, so that you don't scale too high, so that you have a cap about where your the number of resources that you will deploy at maximum load, and then also to look at things within the cloud provider, that like things like AWS WAF or Azure WAF or web application firewall technologies that have DDoS protection kind of built in, that can then stop these kinds of attacks from happening and taking effect on your environment. The other thing is about setting limits. As Victor said, you can set limits on particular resources. So you can set caps on the number of a specific type of resource that you can deploy within your environment as a quota. And the other thing is about what alerts you might want to set up, so that when you are, triggering a certain amount of capacity, to make sure that you have that visibility that is notified to you or notified to the people that are operating and managing your system. Particularly out of hours, you might want to raise like a text message or something like that to show when you have like a non-typical amount of resource, so more than usual for a specific time period. These are all kind of things that you can help to do to manage your costs, or at least to keep on top of it and know what's happening with it.
Okay, thank you guys. Thank you, Jeff. Thank you, Victor.
Thank you.
I'll just round up a little bit to finish off here. We started off by talking about tools, what the customers can do themselves. We touched on, on a level of compute, networking, storage. We moved on then to changing bigger changes, like to different regions, to different services, to still acquire business requirements. And then we finished off with governance, making sure that, what we do and what we review and what we implement is then still in place after we leave. So we also think about as well, when you talk about cost optimization, optimizing means making the best of what you can, but still we need to understand that we have to have security, performance, resilience in place. They cannot degrade because we are cutting on costs. And also what it's all about is as well making sure that you can actually run your business and keep your service levels. So we would thank you very much for listening to us. And I would just like to say that you can see some of the competence we have at Basefarm. So if you're interested in doing cost optimization for your public cloud environment, we are open for a contact. And you can see from these guys what they say. The proof is in the pudding. They know what they're talking about. We're talking about a lot of experience here from these two guys. So thank you, everybody, for listening, and see you next time.
Thank you.